Hi children, we are meeting again, and we have been doing quite a lot of problems on Pythagoras theorem, and I told you Pythagoras theorem is very important, so we have to do as many problems as possible. Today we are going on to continue with the exercises, and today we are going to get a figure called the rhombus. Now you know what a square is. You know what a square is. Now this is a square here. Square. What are the properties of the square? All the sides are equal and all the angles are 90 degrees. And the diagonals are equal. Now what is a rhombus? Rhombus is just a square slanting like this. When a square slants like this, it becomes a rhombus. You can slant that way or this way. So when you slant the square, the properties of the square, or not all the properties, some properties of the square is maintained. What are the properties maintained? That is, all the sides are equal is there. But the angles can't be 90 degrees, but the diagonals bisect at 90 degrees. So the rhombus will come like this. This is a square, this square slanting. So square slanting is a rhombus. Can you see? Now here the diagonals, when you look at the diagonals are bisecting at 90 degrees. Now what is the meaning of diagonals bisecting at 90 degrees? What is the meaning of diagonal? That is, this diagonal is bisecting this diagonal. And this diagonal is bisected. Bisected means dividing into two equal parts. So when you look at it, look at this figure, this is a square which is turned on to rhombus. Now in this, all the sides are equal and the diagonals are bisecting each other at 90 degrees. And they have also given that, we call this ABCD, I will call it O, and they are given that BD as 16. BD is equal to 16 and AC equals 12. They are given like that. BD equals 16, AC equals 12. So if the diagonals are being bisecting each other, then these two parts should be equal. That if AC is 12, this part should be equal to 16, 6 and 6. Same way, if BD is 16, this part should be 8 and 8. Diagonal bisect each other means cutting into two equal parts. So this diagonal is bisecting this diagonal, and this diagonal is bisecting this diagonal. So if the whole thing is 16, this is 8, this is 8. And if the whole thing is 12, this is 6, this is 6. Now can you see, all these four triangles are equal. Because all the right angle triangles, and this is 8, this is 6. Here also, if the right angle, these are right angle, 8, 6, 8, 6, and 8, 6. So the question is, find the perimeter of the rhombus. That is perimeter of the rhombus. That is, you have to find the length of all the four sides. So if we take one triangle, we can find the length of all the other triangles. So we write down DC squared is equal to 6 squared plus 8 squared. This is the hypotenuse, the right angle, 6 squared plus 8 squared. That is equal to 36 plus 64. That is equal to 10, 100. So DC is equal to 10. Now in this triangle, if you take any triangle in the same, so I am taking this triangle. In this triangle, DC squared is equal to 6 squared plus 8 squared, that is 36 plus 64, that is equal to 100. So DC is equal to 10. So therefore perimeter equals 10 plus 10 plus 10 plus 10, that is equal to 40 centimeters. So perimeter of this rhombus is equal to 40 centimeters. We'll take another example. Look at this. Now these are square A, B, C, D, and each side we are going as x, and they are given the diagonal as 10. Now question is to find the area of this square. Now area of the square will be x into x squared. So when you look at the diagram, we can just directly apply the Pythagoras theorem. That is, x squared plus x squared is equal to 10 squared. So that is 2x squared is equal to 100. Therefore x squared is equal to 100 divided by 2, that is equal to 50. Now, how to find the area of the square? Now, we need not find one side separately. Now, area of the square is x into x square. So, x square we already got here. So, x square equal to 50. Therefore, area of the square equals 50 centimeter squared. We'll go through this again. Now, this is a square they are given, and you have to find the area of the square. They are given only the diagonal equal to 10. So, we will take one side as x. So, all the others will be x. So, if we take this triangle, the area, the Pythagoras theorem, x squared plus x squared equals 10 squared. So, that is x squared and x squared, 2x squared equals 10 squared, 10 squared equals 100. So, x squared equals 100 divided by 2, that is equal to 50. So, x squared is equal to 50. Now, area of this square is x squared, x into x squared. So, automatically we have area equals 50 centimeter square. We will take another example. Look at this example. Now, in this, here we have a circle and we have what you call a chord. Now, we must know parts of a circle. You should be knowing. We have a circle like this. We have line through the center is called the diameter, and any line from the center to the circumference is radius. Then any line like this comes as chord. So, here we have PQ as the chord, and this is called the center. So, now we have R as the midpoint. R equals midpoint of the chord. So, therefore, this part equals this part. PQ, they are given it as 12. If the PQ is 12, if this is the midpoint, then this should be 6 and this should be 6. And they have also given the length of OR, and they are given as 8. So, now the question is, find the radius of the circle. Find the radius. What is the radius here? Radius is OQ. So, in this, we straight away we apply the Pythagoras theorem here. Now, here PQ is the chord, and they have given the chord as 12 centimeters. PQ equals 12 centimeters. So, we have R is the midpoint. So, peak R equals RQ 6. So, and they are given OR as 8. So, applying the Pythagoras theorem, OQ squared is equal to 8 squared plus 6 squared, that is equal to 64 plus 36, that is equal to 100. Therefore, OQ equals 10. So, the radius of this circle is equal to 10. We will take one more example on this exercise. Look at this diagram. Now, these are right angle triangle, children, and here we have AB. The length of AB they are given as 8, and P is the midpoint. So, AP equals PB 4. Same way they are given BC as 6, and R is the midpoint. So, BR equals 3 and RC equals 3. Now, the question is to find the perimeter of the quadrilateral, QVAT quadrilateral, the short form of quadrilateral, PRCA. So, that is this four sides. Now, we don't know this side, we don't know this side, we know only this side, we know this side. Now, in this right angle triangle, we can easily find out PR. How? PR squared equals 3 squared plus 4 squared, that is equal to 9 plus 16, that is equal to 25. So, PR equals 5 by Pythagoras theorem. So, we have found out PR as 5. Now, we have to find out AC. For AC, we take the big triangle. How? AC squared is equal to this AB squared or BC squared, that is equal to 8 squared plus 6 squared, that is equal to 64 plus 36, that is equal to 100. So, AC is equal to 10. So, Now we know all the sides of the quadrilateral. So perimeter is equal to starting from here, AP is equal to 4 plus 5 plus 3 plus 10. That is equal to 9 and 3, 12 and 22 centimeter. So perimeter of this quadrilateral equals 22 centimeter. How did it come? Now these are the midpoints of AB. So if the midpoint, then these two parts should be equal. Whole length they are given as 8. Therefore this should be 4 and this should be 4. Same way PC is equal to 6. This is the midpoint R. So BC is equal to 3. BR is equal to 3 and RC equal to 3. So now we don't know PR and we don't know AC, but PR we can find out from this triangle. PR square is equal to 3 square plus 4 square, 9 plus 16, 25, PR is equal to 5. Same way in this big triangle, AB square, that is equal to 8 square, and this is 6 square. So 8 square plus 6 square, 64 plus 36, 100, AC equals 10. So perimeter equals 4, perimeter of the quadrilateral, 4 plus 5 plus 3 plus 10, that is equal to 9 to 12 to 22. So this is all for today, children. I hope you have understood the lessons. If you understand, please subscribe.